Hello, everybody. My name is Yen, and welcome to the Short Pharmaversity podcast. The topic today is how to choose the right vial, part 2, spot on fill and finish, lyophilization, and freezing. Selection criteria and solutions to improve efficiency. To learn more about the impact that fill and finish, lyophilization, and freezing has on the choice of primary packaging, I have with me Diana Löber. Diana is Global Product Manager at Schott Pharma and is responsible for specialty and sterile vials. She leads and coordinates developments for glass vials. As I like to say, Diana is our vials champion. Hi, Diana. Nice to have you here today.
Hi, Jen. Thanks for the introduction. Nice to be here again.
So let's start right away, Diana. Looking at the title, Pooh, this is really a quite long title, Diana.
I know, so shame on me. So I'm so sorry for this, but it was quite challenging to get the message across of what I actually want to talk about in my session. And yeah, so probably I'm quite lucky that in this case, marketing didn't have to approve the title.
Yes, you're right. So let's digest it piece by piece. One thing I can already mention is that this is part 2 because we already had part 1 in last November.
Yes, Jen, exactly. So back then, Neos was my counterpart in this Pharmaversity, and we talked about liquid fills and how to find the right surface for a drug. So focus was more on drug container interaction, how filling volume, storage temperature, processes like, for example, terminal sterilization or pH influence the interaction between the vials in a surface and the drug. And therefore, solution-wise, the focus was on Every Pure, as well as on our inner coated vials, so such as Every Care and Every Plus.
So for this session, it is about fill and finish, lyophilization, and freezing. So let's start with fill and finish. What are the main challenges here?
So it actually starts already with the kind of fill and finish machine, respectively the equipment you choose. So a machine using ready-to-use containers, so pre-washed, pre-sterilized vials in a nest. So for example, our adaptic vials. So using such a technology in which these containers are also process nested has a totally different impact than traditional bulk filling lines.
And why is it like that? So what are the influencing factors here?
So if you do bulk filling, the vials will necessarily experience unavoidable contacts on the fill and finish line, leading to cosmetic defects that then might decrease the vial strength and increase the final reject rates. And in addition, due to this constant glass-to-glass contact, the risk for creation of particles and therefore the risk for sterility issues increases. And these are challenges that are simply not an issue with nested processing.
I understand. So, and what are the challenges that customers might experience when doing bulk filling?
So, as mentioned already, one huge topic is an elevated final reject rate. The vials continuously collect defects along the fill and finish, and this then might end in an increased number of vials being rejected after final inspection. And maybe this is not that big of a deal for very low cost drugs. There, it might not hurt so much to throw a filled vial away. For mid to high value drugs, though, this is an important factor. So only a minor decrease of the reject rate by 1 or 2% has a huge impact.
This I can imagine. If a production of a biologic costs maybe a few hundred hours, you wouldn't want to risk to have to throw it away. So what are the other issues that can occur during bulk filling?
So an additional topic is breakage. So even though we know that glass breakage is something that might occur, it usually only occurs on rare occasions at our customers' filling lines. But if you have glass breakage, it puts the whole production on hold, and it is very time consuming to do the cleanup. This is definitely something that needs to be avoided, and this is strongly connected to the prior topics. So the collected defects that can, not must, have an impact on the vial strain.
Okay, but this also means that the breakage could occur at some later stage along the value chain, right?
So exactly, Jan, you are totally right. It might also happen when a nurse or even a patient him herself uses the container. And it could even happen if, for example, a device is used. So even though it is rare that a vial is used in a device that actually injects the drug directly, it is quite common to use adapters to do the reconstitution of lyophilized vials or to get the drug transferred into a syringe.
And are there any other occasions that pose a higher risk for breakage?
So, I mean, of course, transportation is always a risk factor. So, how to make sure that the vials do not get damaged when taken to the filling provider or being taken to the point of sale later on. And in addition, of course, freezing. So, this can have a critical influence on the risk of breakage.
And what happens during freezing? What is so critical there?
So in general, glass is thermally very stable. But when a formed vial is pre-flawed, so meaning it collected defects during handling and filling, and these defects are strength affecting, the additional stress that the vial is extradited to when being frozen and thawed can result in breakage. And factors that usually impact that risk are the filling volume and the roughness of the freeze thaw process. And regarding the filling volume, the maximum implies the less the better. So it gets really bad though when when it comes to a filling volume above 75%. So there we then really saw a strong increase of the breakage rate.
And what else needs to be considered when doing bulk filling?
So one additional topic is definitely speed. So often the potential line speed is not 100% exploited. And this logically influences the output and therefore the costs. And often the constraint is the filling module, but sometimes this is also related to the vial. So if the vials do not run smoothly, they tilt, they get stuck, they fall over. You cannot use the maximum clock rate available.
Thank you, Diana. So we talked about fill and finish and freezing now, but also lyophilization is mentioned in your title. If I'm not wrong, this needs to be done with bulk vials. So what exactly is the challenge here?
So here I have a correction to make. Yeah. So yes, freeze drying is mostly done in vials. So I do not have an exact number, but my guess would be like something like 99%. But lyophilization can also be done in ready-to-use packaging. So lyophilization can be performed with nested vials. So this was the correction. But of course, if you do this in nested configurations, the packaging density in the freeze dryer might then be lower. But as compensation, usually also the cycle then can be done faster. But one thing that can happen, no matter if bulk or nested, is a phenomenon that is called fogging. So, meaning you have this fog like appearance just above the drug product that is then the lyo cake. And this is a very nasty topic because it occurs very erratic, sometimes even years after the process has been developed and proven stable. And vials that show fogging usually need to be rejected, leading then to elevated production costs.
Thank you for the clarification, Diana. So quite some topics to be considered when choosing the primary packaging. And we only talked about fill and finish efficiency.
So indeed, but this is honestly what I wanted to achieve, to show the complexity, to show how these different requirements need to be considered when choosing your primary packaging.
So we learned about the selection criteria now. But what about the new solutions that Schott Pharma has to offer?
So let's go backwards. The last challenge we discussed was fogging during lyophilization. And one modification that definitely helps to avoid fogging is having a hydrophobic inner surface. And therefore, you can, for example, use silicone. But if you have a biologic drug of which one vial costs, I don't know, maybe even multiple thousands of dollars, you do not want to risk having silicone in your drug or interacting with your drug. And this is why we have a product called Everic Lyo, formerly known as top lyo. And this is a vial with a hydrophobic inner surface based on SiO-CH. And unique about this is that it is covalently bonded, so the strongest bond you can have on molecular basis.
I'm curious, so how is this inner surface of every lyo created? Is that really safe?
So we use our well-established PICVD technology to apply these inner coatings. And PICVD stands for Plasma Impulse Chemical Vapor Deposition. It is a shot patented technique, and its uniqueness is that it ensures a covalent bond between the coating and the glass substrate. And this differentiates it from other solutions used as barriers. And a covalent bond means a bond on atomic basis, so the strongest chemical bond achievable. And the technology works like this. So the vial itself is actually used as a vacuum chamber. So HMDSO, hexamethyl disiloxane gas, is blown into the vial. And easily said, this gas is then split into its components, what is achieved by the application of heat and microwave. And based on how you adapt these parameters, so temperature, pressure, pulse frequency, and duration, different kinds of coatings are achieved that bond to the glass substrate with different properties, fulfilling different purposes.
That sounds very impressive. Another important challenge that you mentioned earlier is breakage. What can be done to reduce the risk with that?
So first of all, the vial itself can be improved in order to show an increased initial strength. So this is what we have achieved with Everix Strong. Everix Strong is a vial made of borosilicate glass, so a normal Taiwan glass vial without any additional chemical or whatsoever treatments. What we have done though, we use an improved tubing, and we have improved its dimension and its cosmetic in order to make it stronger. And this is even reflected in its specification. So as far as I know, Everix Strong is the only vial with a specified strength. And we do specify an axial strength of 2000 Newton and a side compression strength of 1000 Newton.
Okay, but you earlier mentioned that handling can have an impact on strength.
Yes, it definitely can. And this is why we recommend to add an outer coating to it, so Everix Smooth. And this is something that not only protects the vial from defects, but due to its low friction outer surface, it contributes to an improved fill and finish. So speed can be increased, tilting, falling over, sticking and climbing avoided. And thanks to less induced defects, the final reject rate can massively be reduced. So Everix Strong and Smooth represents the perfect match to optimize bulk line performance.
This really sounds perfect. So, is there also a specialized solutions for freeze applications?
So yes, there is, due to the fact that the impact, the stress during freezing is even higher, we have developed a dedicated solution. And basically, we have taken Everix Strong as a basis with all its features, and we have increased the wall thickness. And reason for this is that the goal was to improve the burst pressure strength of the vials, so to make it more resistant for this specific application down to minus 80 degrees Celsius. And this resulted in a vial called Everix Freeze.
Thank you, Diana. So, to summarize, there's Every Lyo, a solution against fogging. There are the strength improved vials Every Strong and Every Freeze. And there's an outer coating Every Smooth that helps to protect the vial and increase line speed. Anything else you want to mention?
So last but definitely not least is our adaptive secondary packaging configuration. So I mentioned in the beginning how important the kind of fill and finish is. And by employing a nested ready-to-use process, you do already avoid challenges instead of having the need to solve them later. And apart from fogging, all mentioned issues are by design prevented to a large extent by using nested processing. No tilted or fallen over vials, no glass to glass contact that increase the risk for particles and creates defects. And these defects then again increase the risk for breakage. In addition, it reduces complexity because washing and depurination is taken care of by us, so the container supplier. So with Adaptic, you get washed and sterilized vials.
And what are your concluding words, Diana?
So based on my experience, the most burning questions we get from customers are related to drug container interactions. So this is definitely the first aspect to be considered, the stability of the drug. Nevertheless, we also see a higher focus on fill and finish. And this is probably mainly due to the shift towards more valuable drugs. So losses simply hurt more, and additional factors probably also lie in the diversity of drugs as well as in the increased requirements by the agencies. And therefore, my final remark is consider the primary packaging at the most early point in order to achieve the best output, not only from drug stability perspective, but also considering fill and finish, storage, and safety.
Diana, I understand you are really our vial champion. So thanks for the interesting talk we had and for guiding the audience through the challenges that the primary packaging might bring to fill and finish and the respective solutions Schott Pharma provides to help our customers improve efficiency and, in the end, safety for the patient. Thanks to the audience for listening and supporting us. We really hope we've triggered good ideas. We hope to meet you soon again and bye bye.
Bye bye.